Ivy is the magic behind the company's best days. Ivy for training and consultancy and outsourcing and talent empowerment. Ivy USA will show how to do the sensitivity analysis and devise an optimal solution.
Sensitivity analysis introduction. Once you come up with an optimal solution, you want to see how sensitive it is to small changes in underlying assumptions and how stable the solution is. So the solution can be pretty stable, so small changes don't actually change that much the results, the end results. But you can be facing also a contrary example, so it actually can be very volatile. And this obviously you would like to avoid a situation where you have found current solution, an optimal solution to be nice, and then to discover that small changes in the underlying assumptions are basically killing it and making it useless. Therefore, it is a great idea to carry out such a sensitive analysis. We'll show you in the next lecture how to do it. But just before we go for this, let's have a look at the reasons why such a sensitivity analysis makes sense. So first of all, volatility means risk, and obviously in business, you rather want to avoid risk, especially the one you kind of build in by your actions by choosing the solution. Then if you can't control it or you can't avoid, you obviously want to prepare somehow for it. So once you know how sensitive the result is, you can prepare for it, hedge somehow against it. In some cases, you may want to choose less sensitive option. So the option you have chosen might be optimal, but very sensitive, and therefore it might be a better solution just to go for something which is not that sensitive, maybe not optimal as well, so a little bit worse, but more durable, more predictable. Sensitivity analysis also helps you to manage expectation. So if you know how sensitive the results can be, you can obviously manage the expectation of your people. If you don't know it, then you might be heading for a difficult surprise. And then last but not least, sensitivity analysis is a basis for managing a portfolio of products. So if you have a high sensitivity of the products you're managing, then you have a huge problem. If some of them are, let's say, very sensitive, it's not that huge of a problem because it's averaging over the whole portfolio. So that's in short, and let's move on to the case. Now we'll have a look at the sensitivity analysis of the revenue for a chain of coffee shops. Please open file coffee shop sensitivity analysis attached to lecture, and let's go to the sensitivity analysis sheet. Here you will see the revenue of the coffee shop retail chain generated using the KPIs, the main drivers. So we have revenues that are being generated using the total number of transactions and the average value transaction. So we can see here that we multiply one by another one. Then the total number of transactions is a multiplication of the traffic and the conversion rate. So how many people bought from us, from those who entered, the visitors. Then the average value transaction in row 10 is just a multiplication of items per transaction. So how many items they bought once they decided to buy something, and the average selling price per item. This gives us the average transaction value. So as you can see, this generates us revenues. And now we want to check the sensitivity of two assumptions. So we did assumption on the conversion. We assume that the conversion will increase by 1 percentage point annually. So from 61, it goes to 62 in 2017. So we've got to 62, then to 63 in 2018, and then to 64 in 2019. And we also did similar assumption on the IPT. So IPT, we assume that it will increase by 0.1 every year. So it goes from 1.3 to 1.4, then to 1.5, etc. So this is the assumptions on the revenue generation. So we did assumption on the increase of conversion and increase of IPT. And now we want to create a sensitivity analysis for those two factors. So in other words, by how much we'll manage to increase the revenue in the period from 19 to 15. So those periods, which we have here, depending on what is the increase planned here. Is it 1 percentage point or lower? And the same goes for increase in IPT. So how we do it? So first of all, we have to create a table with the potential values. And here we have it. So in column C, we assumed certain values for IPT. In the calculation, we have used 0.1, and we want to check what will happen if we change this assumption from 0.1 to, for example, 0.9, 0.8, etc. And then we also going by 1 percentage point up here as well. And we do the same for conversion. So this is in row 18, and you can see that 1 percentage point is our basic assumption, but it can be 0.9 percentage point or 1.1 percentage point, etc., going up to 1.7 and then going to 0.3 down from the 1 percentage point assumption. And now in order to do the sensitivity analysis, we'll be using built-in function in Excel. So first of all, we have to put here the function we want to analyze or use the sensitivity analysis on. So this is this one. So we want to check the difference. And now what you have to do is to get all this area and then go to data, what if analysis, and then pick data table. And here he will ask you where to put the raw input and where to put the column input. So raw input would be K9. So this is the conversion, because from the raw he has to put in the conversion. And then the column input is the IPT, so K12. Then you press OK, and we get the results. I already pre-formatted it so that he shows the highest, lowest. And our starting point was this one. So it was 11, almost 12 million of increase between 19 and 15. And as you can see, we have here all the potential results given the values for the IPT and conversion. So for example, in cell 028, we've got 13, almost 14 million of difference. And this is for the assumption that we increase the conversion every year by 1.4. And we assume that the increase in IPT would be not 0.1, but 0.12. And this is how it works. And here the maximum obviously would be for 1.7 increase of conversion, and then also 0.17 increase of IPT every year. And now let's see where we have a sensitivity. So do we have a sensitivity when it comes to change of conversion? So let's look at the assumption, the initial assumption. So 0.1 was the IPT, and then this shows you the different values for the same IPT and different conversions. So the original one was 11.9 million of difference. And as you can see, it doesn't differ that much. So going down to 10 million and going up to 30 million. Now let's have a look at what would be the change if we just play with the IPT. So we look at the column, the original column where we had the conversion assumed of 1 percentage point. So it's column K, and the initial value was 11.9 million of difference. And here we actually see much bigger difference. So it goes down to 7.6 and up to 60.2. So in other words, the model is much more sensitive when it comes to the changes in IPT than it is to changes in conversion, which makes obviously some logic given that the conversion is quite high. So the 1 percentage point, it doesn't add up that much. But in this way, you can actually check to what assumptions the model is sensitive and then work harder on them. So we out of this, we can see that the model is not that sensitive when it comes to the changes in conversion, but is very sensitive to the changes in IPT. And we should concentrate on modeling them because this is what matters at all. Now let's have a look and see how it would look like in PowerPoint. Sensitivity analysis solution in PowerPoint. Now let's have a look how we can present it in the PowerPoint in a form of slide. So here we have presented the results we got from Excel. So if we change the assumption on the IPT from 0.1 to 0.9 or 0.11, etc., we would get the following values. So as you can see, it is very volatile. So because it's going from almost 12 million to 7.6 million and up to 16.2 million. And when you look at the same revenue growth between 2019 and 15, where the starting point obviously is the same as we had here, but with respect to the changes in the conversion growth, you can see that it's not that sensitive, because in the worst case we go down to 11 million and in the best case we go up to 13 million. So it's much lower volatility than we had in the upper case with the IPT. So in this way you show them next to each other where the volatility stands. So it's here because there are big differences between the results and there is small differences here in the changes in the assumption on the conversion. Therefore, we should concentrate on proper modeling or hedging the risk when it comes to IPT, because this is the main driving force of the whole model.